early on a summer morning, and Sandy wanted to get in a little fishing before breakfast. He wanted Bud to bring the artificial light or sunlight. What is light? Just how does it affect us? The light from the rising sun is always a source of inspiration and wonder. Throughout the ages, men have associated light with truth and knowledge, darkness with ignorance and evil. And although even today there are questions about what light is, we do know a great deal about how it behaves. This is the science of optics. We know that light is a form of radiant energy traveling through space at the amazing speed of about 186,000 miles per second and capable of producing the sensation of sight. You are using your sight to see that Sandy has found a good spot to cast. Like those ripples in the water, light radiates from its source in a pattern of expanding waves. Light waves radiate in all directions in straight lines, sometimes called rays. However, it is easier to study light in terms of a single ray. Just as a stone skips off water, light rays bounce. This is called reflection. A smooth surface gives regular reflection, but a rough surface reflects the light in many directions. We call this irregular or diffuse reflection. It is the light reflected diffusely from rocks, trees, and such objects that enables us to see these things. Reflection, Bud thought. That's what they were talking about after their fishing yesterday. Sandy and Bud like to out simple versions of demonstrations they've seen in the science lab at school. The bright sun pouring in through a tiny hole in the tent provided a ray of light, and with a few simple gadgets, they could see how light behaves. A shiny piece of metal made a mirror. What happens when light bounces off a reflecting surface like this? They could see the angle of the reflected beam as the mirror was rotated. Sandy showed Bud the relation between the incoming light and the reflected. Regardless of the size of the angle, the law of reflection is the same. The angle of incidence, that is, the angle at which a ray strikes the surface, is equal to the angle of reflection, the angle at which it leaves. This principle is true not only for flat or plane mirrors, but also in a slightly different way with curved mirrors. At different parts of the curve, the rays are reflected at different angles. A concave mirror converges the ray, while a convex mirror spreads or diverges them. Sandy said he could always remember concave by thinking of a sort of a cave, hollow. Convex is the other way. These principles are used in the trick mirrors you often see in amusement parks. Bud makes a more practical use of a curved mirror when following his hobby of photography. The interior surface of this reflector is curved so that the light is directed toward the picture-taking area. So that's what happens when light is reflected from things. Now what happens when light goes through things? Well, it appears to go right through this glass. Actually, however, while light is passing through glass, it slows down to about 2/3 of its normal speed. In the air again, it resumes. When the rays enter the glass at an angle, this slowing down and speeding up causes refraction. Rays that enter first slow down first, causing the beam to bend. They also leave the glass first and speed up first, causing the beam to bend back parallel to its original direction, but offset or shifted. When Sandy handed Bud a glass prism, he could see how the sloping sides changed the direction of the beam. Back in the boat, Bud could see refraction as he dipped an oar. Because light coming from the underwater parts of the oar is speeded up when it comes out, the rays are bent, and so make the oar appear to be bent. Right now, Sandy isn't concerned with refraction. He's got a bite. But Bud is going to use refraction in the camera lens to get a picture of this. Just as he was telling Sandy yesterday, light is refracted in a lens. A lens is really a sort of prism with curved sides. The light rays are refracted or bent toward the thick part of the lens. The point at which the rays meet is called the focal point, and the plane in which all such points lie is called the focal plane. A camera is simply a light-tight box with a lens. At the focal plane of that lens is a sheet of light-sensitive film. This is how an image is formed by light rays. Light reflected from, say, the nose of the fish enters the lens where it is refracted and brought into focus on the film. Light from this point on the nose focuses at this point on the film. The same thing happens to the light from a point on the tail and from every other point in the picture area. So it all adds up to an image on the film, which becomes a permanent photographic souvenir and printed in Bud's darkroom. Sandy didn't think the little print did the fish justice, so Bud offered to make him a big one with his enlarger. He explained that the enlarger uses a lens and the same principles of refraction as the camera, except in reverse. Light is projected through the negative and focuses a larger size image on the easel. But Sandy could not see his picture at all if it were not for another marvelous optical instrument, the human eye. Like a camera, the eye has a lens which focuses light rays on the retina. When a person's eyes are unable to focus clearly, his defect is corrected by eyeglasses, lenses which refract the light so the image is focused sharply. A pair of binoculars can be added to the eye's optical system to enable us to see distant objects clearly. A microscope does the same thing for small objects, while the observatory telescope enables us to look into outer space. Did you ever stop to think about the many uses we make of light, the everyday things around us, and the less obvious applications? Motion pictures, television, the electric eye? You can demonstrate for yourself, just as Bud and Sandy did in their own way, many things about reflection from plane and curved mirrors, and about refraction, and what that means to lenses and to the whole science of optics. And there's a great deal more you'll find interesting about the nature of light. For instance, do you know the parts played in this scene by the reflection and refraction of light?